Right, radian measures. Before we get to that, remember that we all should know that we can measure the angle of a circle in 360 degrees. There's 360 degrees, so what they did many years ago, the Greeks or the Babylonians, whoever did it, is that they broke the circle up into 360 sectors, and they said each one of those sectors, the angle is 1 degree. You can measure that by using a protractor. The other way of doing it is by radian measures. Now, radian measures is all about ratios. If you can remember many years ago, when they worked with the circumference, the smart people found out that the circumference of a circle, there's always a relationship. They say that the circumference is the diameter will always fit into the circumference. So the diameter always gain the circumference 3.142 about times. Okay, so 3.1422. So the circumference was that 3.1422 multiplied by the diameter. Depends on how big the diameter is. Okay, but 3.142 was too hard to work with, so they gave that a name, and that 3.142 was then named pi. So we said that the circumference was pi d. It's just a number, and pi d therefore is the circumference of a circle. What we then said is, if we look at only the radius, which is this part, then the radius will be 2 times the diameter, and therefore the circumference is 2 pi r. Okay, so the circumference is 2 pi r. What a radian then is when I take this distance, the radius distance on the outside. So this distance, and I go along that side until that segment there, the distance there on that sector equals this. So if this is the radius, and that is, let's call it the distance. Okay, when the distance is as big as the radius, then this is 1 radian. Then that is 1 radian. Okay, in other words, the most of the radians will be pi times d, or sorry, 2 pi r, because that is r, which means the biggest it can ever be is 2 pi, which is 6.283185 radians. So in one circumference, in one triangle, there's 6.283 radians. That's the most radians there can be in a circle. So 360 degrees equals 6.28. Sorry, I don't know if you see that. So 6.28 or 2 pi. And then from there we can get the following formula. We then say that 180 degrees, I just want to write this, 180 degrees equals pi radians, because in 360 degrees there were 2 pi radians. Okay, so there will always be 2 pi in 360, so in half of it there will always be pi radians. Pi radians is 3.142, but we're not going to use it, we're going to use the symbol pi. You can still get one right. You can get half a radian. Half a radian is when that distance there is only half of what the ratio there is, and that is why radian measures is all about ratios. That's a mouthful. You don't have to worry too much about that. That is where it comes from. The only thing that you need to be able to do is you need to go from radians to degrees and from degrees to radians. That is what you need to be able to do. Okay, so to go to degrees, we're going to use this 180 and pi radians. So radians to degrees, I remember the one that I want to go to is on top. So what I'm going to do is I'm going to multiply. I want to go to degrees, so it's times by 180 degrees divided by pi radians. If I want to go to radians, I'm going to multiply by pi and divide by 180. So that's how I remember it. The one that I go to comes on top, so 180 divided by pi. The only other thing that you need to know is if we leave it in pi, remember we said pi is 3.1482, 3.142, what? If you change it to that, it is just a rounded value. If you leave it in this form, it's called exact values. So depends on what the question is. You rather leave it in exact form or rounded form. The only other thing that you need to know is how this is written. If there's nothing, so just 180 over pi, or sorry, pi over 180 degrees, or if they say the angle is 3, that means it's 3 radians. If there's not a degree sign up here, then it's just radians. Or a C there shows that it's also already in radians. Have a look at the examples following this video.